Hi folks, this is chapter 12, part 1. We're going to talk about perfect competition, the first of our market structures, and specifically how firms choose a profit maximizing level of output. In addition to learning about Q star, we're also going to start using our average total cost curve to understand profit, loss, and break-even outcomes for the firm. As a small aside, this chapter is going to build some skills that will be useful for you for the next 3 to 4 chapters. So make sure that you're comfortable with this material before you move on. Okay, so let's jump right to it. Firms are trying to maximize profits. Profits are equal to total revenue minus total costs. Total revenue is nothing more than P times Q. We know that perfectly competitive firms don't have a choice about price. They have to sell at the market price. And we've already said that they're going to choose the cost minimizing solution in production. So really the only thing they've got to worry about is how much quantity of output to produce. The way that they're going to decide that is based on our golden rule. Once again, they're going to be looking for a quantity of output that has the last unit generating a marginal benefit equal to the cost of producing it. So our marginal cost curve we developed in chapter 11, and you'll see that here. We have not generated a marginal benefit though, which is going to be essential in order for us to use our rule. The marginal benefit curve is nothing more than the equilibrium price. So our marginal benefit of selling one more unit of, let's say, blackberries is equal to the price that we receive for selling that unit of blackberries. Because we're in a perfectly competitive market structure, we are a tiny, tiny, tiny firm. Our production has no influence over the market price. We're too small to matter. That's the assumption we're making. Therefore, what this firm is trying to decide is the quantity of blackberries to produce, and they are weighing what they get out of selling another unit of blackberries against the cost of harvesting another unit of blackberries. As you can see, every single point to the left of this Q star is going to have a lower marginal cost than it would have a marginal benefit. So you could take this Q here and you would see that it is going to generate a much smaller cost, let's say $2, than what you'd be able to sell it for. Let's say that our market equilibrium price is $7. You're going to want to make that unit of blackberries because you sell it for $7 and the marginal cost of acquiring it was only $2. That puts $5 extra in your pocket, so to speak. Of course, every single Q all the way to Q star is going to have a higher MB. You can see that I've outlined it here in green. Then it will have a marginal cost, which is what it's going to acquire, what it's going to cost you to acquire it. You're going to stop when you get to Q star. Q star is your optimal point. If you choose to produce any Qs to the right of Q star, we're going to find out that the marginal benefit is actually going to be smaller than the marginal cost. You pick a Q out here, like this one, and we'd see that you're still only going to be able to sell it for $7, but maybe if you try to harvest that many blackberries, it gets hard to come by them. That unit might cost you $12. You only were able to sell it for $7. So, real simply, the MB is bigger than MC. Keep making more. When MB is equal to MC, stop. And never go beyond where MB equals MC because you're giving your money back away. All right. Let's take a look at how to actually calculate profit using our graphs. So I've got a market here. We'll use our blackberry example again. And let's say that blackberries are currently selling at $12 per unit. Then we know that our price is going to be equal to $12. This is our price. It's also our marginal benefit. You could also think about it as marginal revenue, the extra revenue generated from selling the next unit of blackberries. Okay, so first thing I want you to always do whenever you're working any of these problems is I want you to find the spot where marginal revenue equals marginal cost. That's going to be right here. Once you have that intersection, just like we were doing on the last slide, you know your Q star. Let's say that this Q star is 700. We know that our price is $12, and we know that in order to produce 700, it's going to cost us something. We're going to use the ATC to figure out how much it's going to cost us. Before we get ahead of ourselves, let's look at the revenue side. Keep in mind, profit is equal to total revenue minus total costs. Total revenue is nothing more than P times Q. Our price is going to be $12. Each unit of blackberries sells for $12. Our quantity is 700. We know that's our Q star. So we know then that this height multiplied by this base will give us the area of this green box right here. This green box is our total revenue. Now, total revenues are nice because it's money coming in, but of course it costs us to make that output. We're going to have to figure out what it costs us. And the way that we're going to figure it out is we're going to take an average total cost multiplied by the quantity that we're creating. Our average total cost is going to be incredibly useful because when we take our Q and we actually plug in our Q into our ATC, it is going to tell us how much it costs us to actually produce that quantity. So we're going to go straight up from our 700 until we run into the ATC, and then we're going to go straight across and we're going to ask what's our average total cost when we make 700. And let's say that the graph tells us it is $7. $7 times 700 then is going to give us our total costs. Total revenue minus total costs is going to give us our profits. Our profits are going to be 5 times 700. We're going to have profits of $3,500. And graphically, it is the difference between our green box and our red box as denoted here. Our red box is nothing more than an ATC, which is total cost divided by quantity, multiplied by that very same quantity for the base. So the area of this red rectangle is our total costs. It's going to be smaller than our total revenues, hence we know that the difference between them is our profit. Profit equal to $3,500. Okay, not all firms are actually going to make profits. Occasionally the price that's prevailing in the market is going to generate losses for that firm. You have a price that is lower than their average total cost at their Q star. Let's take a look at that. First things first, find the intersection between MR and MC. Drop down, get your Q star. This is the best output level that's available for them. Let's say that it's 400 units. 400 units selling at $7 a pop is going to generate your total revenue. That green box there, height is the price, the width is the quantity, the area of that green box is your total revenue. In order to make that 400 units though, it's going to cost you something. You plug $400, 400 units, pardon me, into the average total cost, and it will tell you that it is going to actually cost you $8 on average for those units. You got a problem here because the height of this box is 8 and the width is 400. ATC times Q. What you end up with is a red box, as denoted here, that's bigger than your green box. This area that I'm marking in black here is your loss. And you'd be able to see that mathematically also if you plugged in to your equation. Total revenue is price times quantity minus total costs, which we can find by ATC times quantity. And what we see is that this firm would be making $400 in economic losses. Okay, let's do break even next. Some firms make profits, some firms make losses, but in the long run, we actually expect perfectly competitive firms to break even. Reason being is that if they were actually in a situation where their price was very, very high and they were generating large profits, you would actually see that lots of firms jump in. Because if they can make good profits, why not? As they jump in, of course, what happens is they're going to drive this price down. And they're going to continue to keep entering as long as the price is high enough that it's generating profits. They're going to stop entering when the price is actually equal to the ATC. So when the price reaches the minimum of the ATC, we're going to find out that this Q star generates a total revenue box, right? P times Q, that is exactly the same size as the total cost box. Because when we plug Q in to the ATC, we see that we run into the ATC at the exact same time that we run into the marginal benefit line. So total revenue minus total cost is actually profit. Well, if total revenue is the same size as total cost, then profits are, of course, equal to 0. Now, your accountant will tell you that you're still making a profit. That's fine. They're only paying attention to your explicit costs. Economists are going to insist on actually counting your implicit of costs as well, your opportunity costs. So when we say that you're making 0 economic profits, what we really mean is that you're doing just as well as if you did your next best option. And this helps economists tell you whether or not you need to switch. It's possible to be making an economic loss that your accountant would still tell you is a profit. What your economist is trying to describe to you is that if you're making an economic loss, it means your next best alternative was actually a better choice. In the long run, you need to move and switch where you're putting your resources. Now you try. I've got a market drawn in. $9 is the going rate. I've got a couple of numbers over here on the right. I could give you a situation like this, and I could ask you to calculate the profit for me, and I might ask you to graph total revenue, total costs, and profit. So go ahead and pause the video, work through this, draw out your graphs, and calculate your profit, and when you're ready, hit play again. Okay, I hope you realized that we're going to take the market price and we're going to drag it over, and that's how we got our MB line, our price line. It's actually our individual firm's demand curve. And it's perfectly elastic because they can sell as much as they want at that price, but if they try to raise that price, they lose all of their customers. Okay, so price is equal to $9. Once we figure out that this is where we have our MB equals MC intersection, right? Our marginal revenue equals marginal cost intersection. 700 is the best that we can do. So we're going to go ahead and we are going to do P times Q to get our total revenue box. And total revenue is going to be equal to 9 times 700. Right? Total costs are going to be equal to 7 times 700. because when we plug in our Q star into the ATC, it's going to tell us our average total cost, which is $70. 7 times 700 converts that average total cost into regular total cost. And we're going to see that profit then is equal to 2 times 700, or $1,400, the difference between the green and the red box, as shown here in blue.